Hello, my name is Diogo from Team YODAS, and I'm here to talk about how can we promote Austin's waste management and reduction. The world is becoming more conscious about waste, but Austin still faces a few problems. People are producing too much garbage, roughly 50% of all waste. They are not recycling, and collection could be more effective. So we want to tackle this, and on the one hand, we identify critical regions where recycling rates are the lowest, and the demographic features that are influencing those rates. And on the other hand, we try to detect flaws and recommend improvements for the collection of waste, and also predict the future waste production to complement all the other factors. We know that 75% of all garbage can be recycled, but the US only recycles 30%, which is what we found for Austin as well. And here we can see the regions where they have the lowest recycling rates in blue. To find why the reasons behind these recycling rates, we built two regression models, that one for garbage, one for recycling, that try to identify the most important demographical features that are influencing this. In here, for example, for the garbage collection, we see that the rooms per resident and the household income are influencing positively the amount of garbage produced. And if we associate this with each zone and the recycling rates or the garbage produced, we can see for each zone what should we target, which kind of demographic groups we should target to increase the recycling rate of those regions. On the other hand, we know that we forgot that roughly 30% of all garbage collection routes are being operated too frequently. This means that they have very low weight per load ratios. And we clustered the zones into three types: low, medium, and high, regarding the average weight per load ratio. And because we know that external factors might obligate that high collection frequency, we did a conservative estimation where we increased all the clusters ratios to the high weight per load ratio, and this gives us a 5% reduction in CO2 emissions of the garbage trucks. But we built also a model that considers the trade-off between higher fuel consumption and higher loads and more trips, and it gave us a solution for the number of loads for each zone that was able to reduce the CO2 produced by 33%.